So let's start with the chapter number 3, the remaining and continue part of the chapter 3, Science 1. So the last part, as we seen, resistance, then Ohm's law, all that. Now we can continue with the same. Now the system of resistor and effective resistance. A resistor is a two-end component having a given amount of resistance between its and two ends. In several electrical devices, a number of resistors are connected together in a different way. The Ohm's law is applicable to all such connected resistors. So this all resistance, when they connect together, so they are connect in two forms. One is known as series, second one is known as parallel. Now resistors in series, here you can see in the diagram there's three resistance, that is R1, R2 and R3 are connected in the same line, and both the end is connected with the voltmeter. Here you can see the ammeter, these are the batteries, and here it is plug key. The value of current I and the potential difference between C and D is V. The three resistors R1, R2 and R3 are connected in a series in the circuit. V1, V2 and V3 are the potential differences of every resistors R1, R2 and R3 respectively. Then V equals to V1, V2 and V3. So this way we can write down, now we can derive the whole equation of resistors in series based on the diagram. Diagram, it is important. Whenever it asks, you have to draw the diagram. The same, continue with the same. V equals to V1, V2 and V3. Now we know, according to the Ohm's law, V equals to IRS. S is taken for series. Then V1 equals to IR1, V2 equals to IR2 and V3 equals to IR3. This value can substitute here. So there we write down IRS, IR1 and IR2 plus IR3. Now we remove the I as a common, so it's cancelled. So RS equals to R1 plus R2 plus R3. If n resistors are connected in series, then the RS equals to R1 plus R2 plus R3 plus Rn. So this way we can prove the resistors in series. Hope that it is clear to all of you. Now we can see the next part, that is the resistors are in parallel. If the resistors are connected in a series, so which point you have to remember? These points you have to remember. The same current flow through each resistor. The effective resistance of the resistors is equals to the sum of their individual resistance. The potential difference between the two extremes of arrangement is equals to the sum of the potential differences across individual resistors. The effective resistance is a larger than each of the individual resistance. This arrangement is used to increase the resistance in a circuit. So these 5 points you have to remember when they are connected in series, and it is important. Sometimes it asks in the paper to be write down. Now here you can see the resistors in parallel. How the resistance are connected to each other. Here you can see the R1, R2 and R3. Three different lines. So they are in parallel. So when they are connected in a parallel and both the end is connected with the voltmeter and ammeter, plug key, battery, these are the important diagram that you have to remember. That is a different in series and parallel. The figure shows three resistors are R1, R2 and R3 connected in a parallel between C and D. V is the potential difference between C and D. So let I1, I2 and I3 be the currents flowing through R1, R2 and R3 respectively. Then we continue with the derived of the part. Then the total current flowing through the circuit is I equals to I1, I2 and I3. Now RP, P for parallel, be the effective resistance between C and D according to Ohm's law. So I equals to V upon RP. We know the formula according to the Ohm's law. So I1 equals to V upon R1. I2 equals to V upon R2 and I3 equals to V upon R3. So that we whole substitute over there in 1. So we get V upon RP, V upon R1, V upon R2 plus V upon R3. So V is a common, so that we remove. So in the end we get 1 upon RP is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. For n series, we get 1 upon Rn. So this way we can solve or we can derive the expression for the resistors in parallel. Now this 5 point again you have to remember for the parallel. The inverse of the effective resistance is equals to the sum of inverse of individual resistance. The current flowing through an individual resistance is proportional to the inverse of its resistance, and the total current flowing through the circuit is the sum of the currents flowing through individual resistors. The potential difference across the end of all resistors are in is the same. The effective resistance of resistors are connected in a parallel is less than the least resistance of individual resistor. And the last point, the arrangement is used to reduce the resistance in a circuit. So that is the point, important point you have to remember. So hold that we completed our chapter number 3 with this. And so almost you completed 3 chapters in science 1 as you know. Then afterward we start with the next part.